What's up, guys? In this video, I'm going to show you how you can easily and quickly build what I think are some of the best DIY acoustic modules that you can put in your studio. These are the exact same modules that a lot of my engineering control room and this listening studio are built out of. These modules are 4 feet wide by 8 feet tall and 5.5 inches thick. So they're designed to fit in a standard residential room, which is 8 feet tall. Now, if your room is taller, or what's the opposite of tall? Shorter than 8 feet, you can adapt these just by cutting the studs to a different height. So they definitely are adaptable to your room. And the acoustic results you can get with these are really, really top notch. You can approach control room level acoustics if you use these panels, these modules, in the right combination and locations. There are a lot of different designs for acoustic modules out there on the internet. So why would you want to use these ones? Why do I use them? Well, I'm an audio engineer and I need a highly controlled acoustical environment to be able to make mixing decisions about my client's music. I'm critically listening to music, making decisions that need to translate to other listening systems and environments, and I need to be objective. And really, the smaller wall-mounted panels just don't achieve that. And especially in the low frequency range that's dominated by isolated, independently operating room modes. And you have these long modal ringing or resonances that have long decay times. And unless you're using larger, thicker panels with a greater area of coverage, you really don't have the opportunity to rein those in. So that's a really big one. In terms of building these, you can fabricate these from inexpensive and readily accessible materials that you can get at Home Depot. Really, the only spendy part, or the part that you might need to special order, is the acoustic fabric that you could wrap these with that comes from Guilford of Maine. And honestly, that's an optional. Like if you want your panels to look really professional like mine do, you can choose to wrap them. Otherwise, you can do it for very, very inexpensively. And then when it comes to the actual framing, you can do this with a super minimal tool set and zero previous carpentry experience. Like literally a trained monkey could build these panels by watching this video. Other advantages are that these panels are modular. You can easily move these out of your location, store them, and put them into a new room. So like if you're renting, these are ideal panels because they load bear on the floor. You don't need to ding up your walls by attaching all kinds of mounting hardware because they don't hang on the walls. You can literally secure these with a single screw or drywall anchor and a safety strap, or you could let them freestand. You could literally just lean them against your wall with no mounting hardware. So they're great if you rent and you might want to take these to another location in the future. As we move through the video, I wanted to make this super easy for you guys to have access to all the information. So I created a free PDF that you can download, and it's got a full set of the plans, every measurement, a cut list, a list of all of the materials that you'll need with links, as well as a list of all the tools that you'll need and what each one is used for. I've included that in a brand new free acoustics course that goes into all kinds of things from how to build your studio, and that is linked below in the description. Sign up for the course for free, and that's where you can access this PDF. So without further ado, let's get started. I want to give a shout out to Tom from Storm Acoustics. I was filming this one, so he did the heavy lifting on the framing. So thanks, Tom, for your help. We're going to be building 2 of these today, so it's going to be double of all the materials. It's nice if you can batch this stuff together. So if you're going to build 1, it's not that much extra work to build 2. You just cut everything twice. And yeah, so here's the materials you'll need. Don't worry about writing this down because I have that complete materials list in the free PDF that is linked below. It's included in my free acoustics course. And so, yeah, here is what you need. Okay, and then here's a list of the tools that you'll need. Again, I have a full list of the tools and what each one is used for included in the free PDF linked below, but I'm going to divide this into an essential tools list, which is much more minimal, and then some things that are optional to just make your life a bit easier if you have them around, but they're not essential. The first step is to cut your studs. Those are the 3 vertical pieces that are in your frame. I recommend measuring your room height and then cut the studs to be 3.5 inches shorter than that. The reasoning is you have a top and a bottom plate that are each 3/4 of an inch thick that you're adding on top of the studs, and that's on 1.5 inches total. And then I like to have 2 inches of clearance at the top of the module to be able to reach in and attach a safety strap. If you go all the way up to your full room height, first of all, you're probably going to damage your ceiling trying to fit these in, and you're also just not going to be able to reach in to be able to get behind the module from the top if you need to. So I like to have that extra margin. We're doing all of our cuts today with a track saw, just because that's what we have on hand. But actually, this is much easier to do if you just use a speed square as a fence and then use a circular skill saw. Or if you have a chop saw or a miter saw, you could use those as an alternative. Once you have your studs cut, it's a great idea to go into your room and do a test fit for height. So you set the studs up, and then you can increase their height by stacking either a 2x4 offcut or your 2 offcuts from your 1x6s. Basically, you just want to stack those underneath to simulate the difference that the top and the bottom plate are going to make, and double check that you did your measurements right and that the assembled frame is actually going to fit in your room. Next, you're going to cut your top and your bottom plate. So you can take one of your 1x6x8s and you can cut that exactly in half. Although you do need to double check that they're exactly 4 feet long after you do your cut, even if you cut it in half perfectly, because a lot of times the lumber that you get, dimensional lumber, is not exactly 8 feet long. So these need to be finished cuts exactly 4 feet each. Next, we're going to cut the blocking pieces. These serve 2 functions. One, they add some structural rigidity to the frame, and they also create the stud bays to be able to compress the Rockwool bats into. These are each accounting for the fact that there's those 3 vertical studs. So the measurement on each blocking piece is 1 foot 10 7/8 inches. Okay, now that you've got all your cuts done on the cut list, you can lay everything out on a solid flat surface. In this case, we're using a 4 foot by 8 foot piece of OSB because that's the finished dimension of the frame, and it works just to get it off the ground using sawhorses. We are using a drill and impact driver here, and we had some extra 2-inch drywall screws that we're just going to use up for this. Normally, I wouldn't recommend that you use those. I don't like Phillips head screws, so I would recommend that you use 2-inch number 8 Robertson screws. They can be like construction screws or deck screws, easily found at Home Depot. Now, this part is optional. We really like to use an 18-gauge brad nailer to pin the frames into place. And this has just enough holding force to be able to allow you to set the screws without using a second set of hands or some kind of jig. Again, this is optional. You can just have someone else help you with this if you want to, and you want to avoid the brad nailer, but it is a really nice add-on if you build a lot of these. Now you can mark out the position of your center stud. It should be right in the middle of your plate. So that's 1 foot 11 1/4 inches in from the edge. Double check it from both sides to make sure that it is indeed in the center. And once you've pinned in the top of it with a screw or your brad nailer, check that your stud is square by using a speed square when you pin in the bottom of it. Now it's time to screw in the studs. Now, a caveat here for all of you fine woodworkers and carpenters that might be watching this, you can definitely pre-drill these and use a countersink bit if you want this to look perfect. But in the same way that you would never do that with wall framing because it gets covered, same concept here. I just prefer to work quickly and efficiently and carefully set the screws. But this is getting wrapped with fabric if you do this the way I do, so you're never gonna see the actual completed frame underneath. So why bother with that stuff if it takes extra time? Once you've completed the first end of the frame, just go around to the other end, rinse, and repeat. Next up, we're going to add in the blocking pieces that will add some structural rigidity to the frame, as well as create those bays that will properly compress the bats of Rockwool. Attaching the outside edges of the blocking pieces is easy because you have access, but where they connect with the middle center stud, you're going to need to, for the second piece, toenail the screws in from an angle. And again, if you were seeing this frame, you would do this differently. You would use some type of joint or maybe pocket screws, but in this case, nobody's ever going to see this. It's going to be covered by Rockwool and wrapped, so just do it the quick way and toenail things in. The nice thing about brad nailing things in is they're pretty forgiving. If you misalign something, you can just use a hammer and tap things into place so they're right in the sweet spot. I should mention that we're using 3 screws to secure each section of the frame. If these were load-bearing, first of all, you'd be using different framing lumber, thicker stuff, but these are not bearing any load, they're not structural, so 3 screws are gonna do the job nicely. Now that we've got the completed frame, our next step is to add a sheet of landscaping fabric. We use this because it comes usually at exactly 4 feet wide, and it fits the module perfectly. It's inexpensive, and you can staple it. It's structurally strong enough to be able to hold into place with staples, and you can blow through it. So if you want to add it to the front as well as the back, it's going to work. So we use an electric stapler to be able to add this in. We're using an Arrow stapler that has T50 staples, and those are nice because if you mess up and you need to pull a staple out, you can easily pull them out using the tip of a bread knife or a butter knife. Just a quick note about the landscaping fabric if you're wanting to put it on the front. I usually don't if that's the final layer, because although you can blow through it and it will work with porous absorption, it doesn't have enough airflow through it that it's going to not be reflective to a degree at high frequencies. So if you are going to use it on the front, then you're also going to want to wrap it with a layer of Guilford of Maine acoustic fabric for sure, because that will handle any super high frequency reflectivity, because the GOM fabric does absorb a bit of sound. Once you have the landscaping fabric all pinned with the stapler, then you can just use a utility knife to cut it to length at the end. Once you've completed the landscaping fabric, you can flip the module over and begin the install for the Rockwool bats. These have been bagged up for a kind of unknown amount of time, sitting on a shelf in Home Depot, so it's a good idea to fluff these up and kind of form them into shape just using gloves. And I will mention, when you're working with this stuff, it is a good idea to wear safety glasses and a dust mask. Rockwool does only recommend using that type of PPE if you're working indoors, but I don't like to mess around with that stuff. So even though we're outdoors, I still like to use safety glasses, gloves, and a dust mask just to prevent any possibility of breathing in one of the fibers by accident. These bats are 2 feet by 4 feet, so 2 of them are going to fit perfectly in the stud bays without being cut, and then 2 of them in the upper section of the frame are going to need to be cut slightly to height, because we went with completed frame dimensions that are less than 8 feet to allow that access up top. Like I said, I want to take a sec here and just talk about the type of Rockwool that we're using. So any type of mineral wool or porous absorption will come in different densities and depths. This is something I'm going to go into in a lot of detail in a different video, but just real quick, we're using Comfort Bat R22. So it's 5.5 inches thick. It has a density of 32 kilograms per meter cubed, which is really ideal for this type of application. The absorption coefficients are really, really good on this stuff all the way into the low end. And as long as you are air gapping this from a wall, it's going to be really, really effective, even down into the base range. So you can get higher density and lower density products, and you have to have an understanding of how density and thickness play into absorption. But again, detail on that in another video. For now, I just wanted to mention the specs on the Rockwool that we're using. Cutting the Rockwool is actually really easy. It's not really a rigid bat, so you're going to want to use some type of insulation knife. That's what we're using here, but a standard serrated bread knife can really do the trick as well. You'll want to line up, after you do your measurements, some kind of straight edge. We're just using a carpenter's square for this. Any type of straight edge will do, just to make sure you get a nice good cut. And there is a bit of a technique with it, but it's pretty forgiving if you mess it up. And again, this is being wrapped, so if it's not perfect, don't fret about that. It's going to be wrapped in fabric. The bats should fit nicely into the frames and be held in place by the friction by slightly compressing them without the bat bulging out of the frame. If the bat is starting to bulge out, that means you probably need to cut it just a little smidge more. So they should fit in there really nicely and be held in gently by friction to keep them in place. Once you've gotten all the bats placed, then it's time to wrap the front of the module. There's a few different options here, and I'm going to show you how we chose to do it in this case. I was actually storing these for a while before they were being used, so I chose to just use a layer of the landscaping fabric on the front as well. Now remember, like I said before, if you're using landscaping fabric just because it's cheap, to wrap on the front, you need to understand that it is potentially going to reflect some of the high frequencies that hit it because it doesn't have enough permeability through it like a normal open weave acoustic fabric. So plus it doesn't have a great look. So really this is like the low budget solution. It's not ideal. So we placed a layer of landscaping fabric on the front, but then I went ahead and ended up wrapping these modules so you get this finished look like they are behind me here with the Guilford of Maine fabric, and underneath the Guilford of Maine fabric there's a layer of cotton batting. I didn't want this video to turn into a big sprawling long piece. It's long enough already. So I left the wrapping process, which is actually quite intricate to get it right, for another video. So I will link that video below the description of this one so you can follow along to part 2 and see how everything was wrapped. Or if you're okay with the look and you don't mind the possible reflection of some of the high frequencies from the landscaping fabric, you could just stop here and use these as is. All right, folks, so there you have it. You are all equipped to build your own acoustic modules. Now remember, I have put an entire plan list, cut list, tools, materials all together in a full-featured long PDF, detailed PDF for you, so you can follow along without having to review this video. That's available as a free download in my acoustics course. There's a link below this video to grab that. It's entirely free, no BS. You can just sign up with an email address, grab the download, and then you get access to everything else in that acoustics course. In that course, I teach you everything from how to orient your room correctly, how to set up your speakers, the ideal positions for your speakers in your room. I talk about all kinds of the common mistakes that people make and how to avoid them. We talk about how to do acoustic testing and room EQ, and that's just the starting point. I'm going to be adding a lot of material to the acoustics course going forwards, and if you sign up now, you'll have access forever for free. So I highly encourage you to come back and sign up for that and check out the content as it unfolds. Right on. If you like this video, give it a thumbs up, smash that subscribe button if you haven't already, and I would love to keep in touch with you. Happy music making, and I'll catch you on the next one.